All right, welcome back to WeBWork 5.5 alternating series. We are given slightly more difficult problem this time around. -2 to the power of n plus 1 over 5 to the power of n minus 1. Um, and our first task is to identify b of n. And to do that, we need to uh, factor out the alternating nature of it so we can isolate b of n. So to do that, we need to find this, and factoring out our -2 to the power of n plus 1 gives us two to the power of n plus 1 over 5 to the power of n minus 1. And that's always how these questions are going to go. That you're pretty much just getting rid of the negative sign. So this is our b of n. Now we need to uh, check the conditions. So let's simplify b of n. Now we know b of n is equal to 2n plus 1 over 5n minus 1. So we just to simplify that, so we can get this to be 2 times n, and this, since 5 is -1, 2 to the -1 times 5 to the power of n. And that's just because the powers for each of them are different. That's why the 2 is +1 and the 5 is -1. The -1, though, we can move up to the numerator. So we have 2 times 2 to the n times 5 over 5 to the n, which is just 10 times 2 to the n over 5 to the n, which is just 2 times 2 over 5 to the power of n. And taking the limit of this, we don't really care about our constant, but taking the limit as well, we care about the constant if it's going to be anything other than 0 and infinity. But as n approaches infinity, for 2 over 5 for n, that's equal to 2 over 5 to the power of infinity. And since 2 over 5 is less than 1, um, this number is going to get smaller and smaller and smaller each time it grows, because it's a fraction. So that means this limit is equal to 0, which means condition A is satisfied, which is perfect. And now the next condition, we need to find b plus b of n plus 1, which is equal to 2 times 2 over 5 to the power of n plus 1. B of n is equal to 2 times 2 over 5 to the power of n. Once again, as our explanation in A, as n gets larger, where n will always be larger than this n, this fraction will be smaller and smaller, which will make b of n plus 1 always less than n, or b of n. There we go. Yeah, and the 2 is the same, so again, doesn't really matter. All that matters is this. But that fulfills our condition B. And based on those results, we can conclude that this converges via alternating series tests as a solution to question 2.